Hello dear students, welcome to the class. In today's class, we'll be revising the further topics in the second chapter, that is principles of electricity. So in today's class, we'll be seeing the voltage divider rule and few numericals based on voltage divider rule. This voltage divider rule is basically called as the applications of Kirchhoff's law. Okay, let's start with the voltage divider rule. Voltage divider rule. First of all, it is applicable to series combination of resistors. It is applicable to series combination of resistors. Okay. So let's see it through a circuit. This is the voltage V, and there are two resistors connected in series, R1, R2. So which two voltages drop? V1 and V2. Okay. So what happens in this voltage divider rule is the total voltage V is split between the two resistors R1 and R2, and that voltage is given by IR drop. A current I flows through it, and that product of this I and the corresponding R, that means R1 for V1 and R2 for V2, is given as the voltage across R1 and R2, and the total voltage V splits as R1 and R2. Okay. So individually, how to calculate the voltage drop across R1 and how to calculate the voltage across R2 is what is voltage divider rule. So now what happens? V1 is equal to, just now I have told you V1 is equal to I into R1, and V2 is equal to I into R2. Okay. Now what is I? How we can write the I? I here, the circuit I in this, I in this circuit. What is the value of I in this circuit? And I is equal to V by R. And what is R? R is the total of the two resistors connected here, and the two resistors connected here are in series. That's why the total resistance is going to be RT is equal to R1 plus R2. Okay. So V is V by R1 plus R2. Okay. V by R1 plus R2. So now the value of I is V by R1 plus R2, so that we can substitute here. So we are going to get it as I is equal to V by R1 plus R2 into R1. Okay, I into R1. This R1 remains. So here we can get the expression. This expression is the voltage divider rule expression. This is the voltage divider rule. The voltage across any particular resistor is given by the total volt, the main voltage divided by total resistance into the resistance. Okay. Here, the voltage across any particular resistor is given by the voltage V divided by the total resistance RT. If we represent it as RT, then the total resistance RT into the resistance R1. If R2 means R2. So here we term it as Rn. N is 1 or 2. Okay. So V, in general, this expression can be written as Vn. It is applicable to any voltage V1 or V2. Vn is equal to V by RT is the total resistance into Rn. The resistance through which we are calculating the voltage is the Rn. This is the total resistance. Clear? So in general, the voltage across any resistor N is given by Vn is equal to voltage V divided by total resistance RT into that resistance Rn. Clear? So this is about voltage divider rule, which is applicable to what? Series combination of resistors. So this is called as the applications of Kirchhoff's law. Next, let us take one example. Here, the voltage value is 3 volts and the resistance is 1 kilo ohm and 2 kilo ohm. So, what is the value of V1 here? So, now V1 can be given as V1 is equal to, what is the value of V1? V1 is equal to V divided by R1 plus R2 into R2. So what is V? It is 3. 3 divided by R1 plus R2. R1 plus R2 is 3 kilo into R1. That is 1 kilo. So 1 kilo gets cancelled. This 3 and 3 gets cancelled. So V1 is equal to 1 volt. Similarly, V2 is equal to 3 by 3 into 2. Okay, that is the V1. So like this, using the voltage divider rule, we can calculate the voltage across the resistor R1 and R2. This is one of the examples. Now let's see the current divider rule. Current divider rule. So the current divider rule, what does it say? First of all, applicable to parallel combination of resistors. Parallel combination of resistors. It is applicable to what? Parallel combination of resistors. This is the voltage. It's the main I. Main current I. R1, R2. I1, I2. Okay. That's this. So the current I1 is given by I is equal to what? V by R. V by R1. I2 is equal to V by R2. V by R1 and V by R. And what is V? V is equal to I into R. So I1 is equal to V is equal to what? I is this main current. I into R T, total resistance, divided by R 1. Okay? I2 is equal to I into total resistance divided by R. Now, total resistance RT as it is a parallel combination can be written as R1 R2 divided by R1 plus R. Now we will substitute this RT in I1 and I2. So I1 is equal to R1 R2 divided by R1 plus R2. I okay, whole divided by R1. So this expression can be written as follows: I T2 R1 R2 divided by R1 plus R2 into 1 by R1. So this R1 is cancelled. Okay. So the final expression for I1 is going to be I1 is equal to I into R2 divided by R1 plus R2. So how we are getting this expression? If we want to calculate the value of I1, we have to consider R2 in the numerator. If we consider I2, if we want to calculate I2, we have to consider R1 in numerator. So it is just about the opposite one. This is R2. If we want to calculate I1, numerator has R2. If we want to calculate I2, numerator has R1. Okay, let's start this. So how we got this? I2 also you will see. I2 is equal to substituting the value of I is equal to what? Sorry, substituting the value of R, T. I is equal to R1 R2 divided by R1 plus R2 whole divided by R2. Okay, whole divided by R2. So this can be further written as I into R1 R2 divided by R1 plus R2 into 1 by R2. So this R2 is cancelled and I2 is equal to I1 into this is the expression for I2. So if you want to calculate current I1, numerator has R2. If you want to calculate the current I2, numerator has R1. This is about the current divider rule. Three volts that I is dividing as okay. And I is 2k and 2k. Both are 2k. Okay. So what is the expression? I1 is equal to calculate value of I1. I1 is equal to I into R2 divided by R1 plus R2. So we require this value of I here. We need the value of I here to calculate it. So I is equal to what? D by RT, total resistance. So what is the total resistance here? The total resistance is going to be 2 resistors are connected in parallel of same value means it is going to be the half, that means 1 kilo ohm. So 3 volts divided by 1 kilo ohm is nothing but 3 milliamperes. Okay. Here. So now substituting this 3 milliamperes, 3 milliamperes into 2k divided by 4k. Okay, this and this gets cancelled. So this becomes 2 and this becomes 1.5. So the value of I1 and is equal to I2 is equal to 1.5 milliamperes. Both I1 and I2 will be equal because both the resistors 2k are equal. This is about the current divider. Now let's see the resistance. In that first one we will be studying the superposition theorem. So what does the superposition theorem say? Superposition theorem says that in any linear bilateral network, the total current is resulting due to each voltage source acting alone. Okay, here. Here there is one voltage source. We call it as V1. Here there is a resistor. Here there is a resistor. One more resistor and one more resistor. We are interested in only this current. So there will be some current due to this voltage source, and there will be another current due to this voltage source. Okay. Due to two individual voltage sources, there will be separate two currents resulting. Okay. Here there will be one current resulting due to this V1, right? One current resulting due to this V2. So what Superposition theorem says is the current that is flowing through this resistor is the sum of a current flowing due to this resistor and the sum of current flowing due to this resistor. Okay, here the current flowing through this resistor and the current flowing due to this voltage source and this voltage source, whatever currents will be flowing, the sum of that will be nothing but the current flowing across this resistor. Here. So what does this say? The statement: in any linear bilateral network consisting of two or more independent sources, the resultant voltage or current through the resistor is the sum of current or voltage due to the voltage sources acting alone. Okay. Here, so it is totally about how much voltage or current is resulting due to one voltage source, and the same with other voltage source. The sum is going to be the resultant. Here, so now let's take an example of superposition theorem. Numerical. Yes. Find the current through voltage across 3 ohm resistor. Find the current through the voltage across 3 ohm resistor. Okay, and the circuit is 2 ohm, 6 ohm, and 3 ohm. 2, 6, and 3. And there are 2 voltage sources, 10 and 15. 10 volts and 15 volts. Here. So now we will calculate what current is flowing through this 3 ohm resistor due to 10 volts, and what current flows through this 3 ohm resistor due to 15 volts separately, and then we will add it to get the total current I. So we need to calculate the value of I. To get the value of I, we need the value of I dash and I double dash, and I dash plus I double dash is going to be the I. Okay? Here. So here in the superposition theorem, we need to go by the circuits separately. Okay? So first one, the first circuit. We need to calculate this I dash. Okay, we need to calculate that I dash. To calculate the I dash, what we have to do now is, this is 10 volts. Here, we need to first of all calculate the main current, this, and then we can calculate the value of this and that. Here, so this is 2 ohm, this is 6 ohm, and this is 3 ohm. Right? So the total resistance RT. To calculate I, we require the total resistance RT. So the total resistance RT is 6 into 3, parallel combination of this 2. 6 into 3 divided by 6 plus 3. Okay. 18 by 9, that is nothing but 2 ohm. 2 ohm plus 2 ohm. This total plus 2 ohm is equal to 4 ohm. Parallel combination of this 2 plus this. So that is total is 4 ohm. So that I am denoting as small letter I here. So that I is nothing but I is equal to V by RT is equal to 10 by 4. Okay, that is nothing but 2.5 amperes. This current 2.5 amperes is flowing here. Here. So now we can calculate from this current applying the voltage divider rule. Sorry, the current divider rule. We can calculate what is the value of I dash. So I dash is equal to I into, if you want this means you have to consider this one. So I am directly writing the values 2.5 into this current 2.5 I into 6 divided by 3 plus 6, that is 9. So this is 3 2s, this is 3 3s. Okay, this is nothing but 5 by 3 amperes. Okay, 5 by 3 amperes. That is roughly around 1.333. Okay, right. So the value will be 1.666. I dash is equal to 1.66 amperes. Okay, here. Now we got the I dash. Now we will calculate the I double dash. Two ohms, 6 ohms, 3 ohms, 15 volts. Now we will calculate I double dash. Okay. So for that, first of all, we will calculate the root resistance RT, where RT is the parallel combination of 2 and 3 plus 6. That is nothing but 6 by 5 plus 6. 1.2. This is 1.2 and this is 6, so 7.2 ohm. Right? 5 ones are and 1 is left. So 10. That is 2 are. So 1.2 plus 6 is 7.2 ohm. Now this current I again we are denoting it. So now the I is 15 by 7.2. So what is this 15 by 7.2? 15 divided by 7.2 is 2.08. 083 amperes. Okay. Now I double dash. I double dash is 2.083 into 2 divided by 5. Okay. 2.083 into 2 by 5, that gives you 0.833 833 amperes. This is I double dash. Okay. So there is a current I dash that is resulting due to 10 volts, and there is a I double dash that is resulting due to 15 volts. Okay. And the total current that is flowing through the 3 ohm resistor now will be the sum of I dash and I double dash. So the total I, okay, current through 3 ohm I is I dash plus I double dash, and that is given by 1.66 plus 0.83. Okay, that is 9. 2.49 amperes. 2.49 amperes. Right? Here 2.49 or 2.5 also we can round it off. Yeah, so this is the solution using the superposition theorem. Okay. Let's take one more example now. Find the current through 12 ohm resistor. Now find the current through 12 ohm resistor, and there is the circuit is There is another resistor and a voltage source here, and one more resistor. Okay. 3 ohm, 6 ohm, 12 ohm. 3, 6 and 12, and we need to calculate the current through 12 ohm resistor. Okay, and the voltages are given as 28 and 12 volts. 28 volts and 12 volts. Here, so we can just rearrange this circuit to get the easier calculations. So I'm just rearranging this circuit and just shifting this in the middle, and I'm rewriting the circuit. So the circuit can be rewritten as 12 ohm. All the branches are in parallel, so there is no difference if we place any resistor in any sequence. Okay, we can place it there also, this here, and in any manner these set can be arranged as they all are in parallel. Okay. Now we need to calculate the current through this, that is I. For that we need to draw the I dash and I double dash values. This circuit, now I am writing it for the calculation of I dash. Now I am writing it for the calculation of I dash. So for the calculation of I dash, what I am doing? I am just replacing this resistor by short. So what I am left with 3 ohm here, 28. 6 ohm, 12 ohm, 3 ohm, and 28. Now the 12 volt supply is replaced by a short. It is just removed from the circuit, and we are considering only the voltage source 28. Okay. Now due to this, I close and we need to calculate I dash. So first of all, do that we need to calculate the total resistance. This parallel combination plus 3. Okay, 12 into 6 divided by 12 plus 6 plus 3. Okay. This is nothing but 72 divided by 18 plus 3. Let's see what is 78 divided by 18. That is exactly divisible, and that is 4 and 3 is equal to, is the value 7 ohm. Now I is equal to what? By R. It is 28 by 7. That is again nothing but 4 amperes. Okay, so the value of I here is 4 amperes. Now what we have to calculate is, using the current divider rule, we need to calculate I dash. So the I dash value is nothing but I, that is 4 amperes. When it flows to this, so consider this 6 divided by 12 plus 6, that is 18. Okay. Here, this is nothing but 3 plus, so the value is 4 by 3. I dash is 4 by 3, 1.333. I dash. Now we got what? I dash. Now we will calculate I double dash. 12, 6 ohm, 12 ohm, and 3 ohm. We need to calculate I double dash. We need to calculate your I double dash. For that, we require this I first of all. Now to calculate this I, we require RT total resistance. Now total resistance RT is given by parallel combination of 3 and 12 plus 6 ohm. Okay. Yeah. So 12 3 are 56 divided by 15 plus 6. That is 6 divided by 15 plus 6. Right? 36 divided by 15 is 2.4 plus 6, that is 8.4. 8.4 ohm. Okay. 2.4 and 6, that is 8.4 ohm. I. So this is what I. After getting this total resistance RT, we need to calculate the current I, where I is given by 12 by 8.4. So what is 12 by 8.4? 12 divided by 8.4 is 1.42. 1.42 amperes. So now current I double dash is given by 1.42. 1.42 into 3 divided by 15. 1.42 into 3 divided by 15, that is 0.84. 284. 0.284. This is I double dash. Right? So now total I is equal to I dash plus I double dash, and that is given by 1.33 plus 0.284. Right? 1.33 plus 0.284, that is 1.6. 1.61 ampere. So the total current flowing here is 1.61 ampere through this particular resistor. Yeah, 1.61. This is the solution. So what we have to do here, first of all, I have just rearranged the circuit in this form so that we can easily draw the further circuits and we can make the calculations easier. Right? Next, after drawing that circuit, we have replaced 12 volts voltage source there by a short, and we got the circuit like this. Now from the circuit, first we need to calculate the total resistance, then the current, and then current divider rule there. Yeah. So total resistance is 7 and 4 ampere is the current. From that 4 ampere current, here we calculate from the current divider rule 4 into 6. If we want to calculate the current from this, consider the opposite resistance. So 4 into 6 divided by 12. The total of these two, addition of these two, that is 18. That is going to give you 1.33 amperes. This is the I dash value. Similarly, we need to calculate the current flowing through this resistor due to 12 volts. Okay. So now in that case also we will draw the circuit like this, and then we will calculate the total resistance and the main current of this particular circuit where we have replaced the 28 by short. Now what we do after this, we will calculate the once we get the main current, we will apply the current divider rule to calculate the I double dash. So here to calculate the I double dash, what we have done, when we want to calculate the current through this resistor, we have to consider the opposite resistor. So this main current into 3 ohm divided by the total 12 plus 3 is 15. That gives us 0.284. Okay. Now, this I dash and this I double dash added together gives the value of the total current that is flowing through the 12 ohm resistor. So that is the sum of these two, 1.33 plus 0.8284. So that is 1.61 ampere is the total current that is flowing through the 12 ohm resistor. So such questions will be asked for superposition theorem. In the next class we will study Thevenin's theorem and maximum power transfer theorem, where we will be completing the network theorems, and also we have already completed the Kirchhoff's law and current and voltage rule. So what does the current divider rule say? Whenever you want to calculate the current across any particular resistor, consider the opposite resistor in the numerator and the sum of the two resistors in the denominator into the main point. Okay. For the voltage divider rule, when they are connected in series, first of all, the voltage across any particular resistor is the voltage into that resistor divided by the total resistance, where the total resistance is nothing but the sum of the two resistors, right? So like this, we have studied the current divider rule, we have studied the voltage divider rule, then we have studied the superposition theorem, and we have worked on two numericals. So what does the superposition theorem? Here we have practically seen the application, how the superposition theorem is applied. Okay, not just the statement, and also how to apply this to any network or any circuit we have studied here. That is with the help of this circuit. This is a given circuit, and we need to calculate what current flows through this particular resistor. Just for the simplicity, I have rearranged this circuit, and individually we are calculating what is the current flowing through this due to 28 volts and due to 12 volts separately, that is individually. Okay. So that we have calculated as I dash and I double dash, and the total I dash and I double dash added together gives the I and the total current flowing through the 12 ohm resistor. Right. So this is about the superposition theorem, where current through any particular component is nothing but the sum of currents that are resulting due to each voltage sources acting alone. Each voltage source is acting alone. Yeah, this is about the superposition theorem, right? Next is Thevenin's theorem and maximum power transfer theorem. I will be covering in the next class with the theorem as well as numericals. I am focusing more on numericals, right? This is about today's class, students. Thank you.